Hello everyone, myself Paula Makwana, Assistant Professor of EC Department at LJ Digital Media Technology. Welcome to the session of Digital System Design. So, from unit number 2, that is a combinational logic circuit design, which we have studied different types of combinational logic circuit, right? So another example of combinational logic circuit is magnitude comparator. Now what is magnitude comparator? It is nothing but a digital comparator, which it is a combinational logic circuit first of all. Apart from that, it is a digital comparator which is used to compare the value of two binary digits. There are two types of digital comparator, identity comparator and the magnitude comparator, right? So the identity comparator is the comparator which has only one output terminal for A is equals to B, either it is high or low, whether A is equals to B is equals to 1 and A is equals to B is equals to 0. That means if both are equal, then 1. If both are not equal, then it is 0. Right? So this is the identity comparator. Second is magnitude comparator. So this comparator has three outputs. What are the three outputs? A greater than B, A equals to B, and A less than B, depending on the result of the comparison. Alright? One of these output will be equals to 1, or it is the height. The block diagram of this magnitude comparator, which we can see, is like this. The bits of A and the B are going to be compared with the help of magnitude comparator. Okay? So the bits are going to be applied to the n-bit digital comparator. So the lowest significant bit of A is going to be compared with the lowest significant bit of B. Alright? So for n-bit comparator, n-bit of A and the n-bit of B are going to be applied to the n-bit digital comparator. So there are three outputs as we have discussed, and this is the magnitude comparator. A equals to B, A greater than B, and A less than B. Alright? So the one-bit magnitude comparator will compare only a single bit of inputs. Alright? How? Let us take my inputs are A and B, and these all are my outputs y1, y2 and y3. A less than B, A equal to B, and A greater than B. Alright? So this magnitude comparator will compare this single bit of A with single bit of B. Alright? Let us study this truth table. Over here, A is equals to 0 and B is equals to 0. What will happen? Both are equal. So which output will going to be 1? This output. A is equals to B. That's right. What it is 1. Remaining are 0, 0. Now A is equals to 0 and B is equals to 1. So A is less than B. Okay, that's right. Y1 will becomes 1 and these two are 0. For the input, A is equals to 1, B is equals to 0, right? So A is greater than 1, greater than B, sorry. That's right, this output will become 1. Now A and B both are 1, that means both are same. That's right, Y2 is equals to 1. Alright, so this is a proof table of 1 bit magnitude and magnitude. Now how to draw a K-map for all three outputs. So let us take the first output Y1 and we are going to make the K-map for designing of that combinational circuit. Okay. So which type of K-map that we can use? As there are two inputs, so we are going to use a two variable K-map. Right? A and B, both inputs are there. So A dash A and B dash B is there. So for which state we are getting the output? When there is only one state, that's A dash B. Right? So Y is equals to A dash B. This is the K-map for Y1 in which the A is less than B. Similarly, for Y2, what is Y2? The output for A and B both are 1. So over here we are getting the two ones at this position. I can say A dash B dash and the AB. So A dash B dash plus AB will be the Boolean function for the output Y2. Alright. Now for the last output Y3. So this is the K-map for Y3 in which there is only a single one. See. So this is for value of A is equals to 1, B is equals to 0. So AB dash. We can also directly written from this Y3 is equals to AB dash. Right? So now our next task is to design the combinational circuit. So for Y1, what is the output? A dash B. For Y2, it is nothing but X NOR gate, and for Y3 it is A B bar. Let us draw its circuit. So A and B are the inputs, and complement of A will be A bar, complement of B will be B bar. So A bar is going to be ended with the B, will be the output Y1. You can also directly use the X NOR gate, but also we can use the combination of AND and OR like this, AND OR and NOR, like A dash B dash and AB with the help of AND gate, and resultant will be applied to the OR gate. And for the Y3, A B bar, alright, that is for A greater than B. So this is the realization of one bit comparator. Right? This is what I have discussed with you. Y1, Y2 and Y3. We can also use it for A is equals to B, X or A. Alright. Now, We have seen the one bit comparator, which it compares the magnitude of the applied input. But if for single bit, okay, what if we need to compare the two bits? So we are going to apply a 2-bit comparator. So 2 bits of A and 2 bits of B are going to be compared with the help of 2-bit comparator, which has again the same outputs y1, y2, y3 as we have discussed for single bit comparator.